Hello everyone, welcome back to channel. So today is day 8 of solving this sliding window patterns and problems. And this problem is also the last in this series. So in the previous series, we saw the fixed window, which had four problems, and this is the sliding windows playlist, and this is the last problem in that. So in this, we are using a sliding window maximum technique, and we will be using the Deque. So the problem statement is you have an array of certain numbers and you have an integer k. You have to return an array of the maximum value in each sliding window. Earlier what we were doing, we were adding or removing the things from the sliding window, and whatever is left that we were showing. But here from the each sliding window you have to show the max and get that into a certain other variable, and then that will be your final output. So why this problem is hard? Because it's not very intuitive when you get to know this. So whatever I said before, that max of each sliding window you have to find, right? So this is a pattern. You would be given certain problem which would be saying you have X or certain you have to do Y, and then you have to think whether you have to use this pattern or not. So it requires monotonic Deque concept. Mostly everyone tries to solve it by heap, which has, as you know, a complexity of O(n) log n. But this is an O(n) solution. Okay. So the key idea behind is we use a Deque, which is a double-ended queue. Always remember, when you have certain things, you have to use a double-ended queue to store indices. And why we are using this is also built upon on the previous problems, that to check if element is out of window to access values from numbers. So the core logic is we remove indices out of window from front, and we remove smaller elements from back. Okay, and then we add the current index, and every single way whenever you're doing the code loop or everything, the front of Deque is the max of window. Okay, so now we'll go back to the solution. So I have created a small function, max sliding window, which takes a numbers and a k. So this is like const is this, and const k equal to 3. So this is your like this. Now in this, we have a TypeScript where we have written Deque will store indices, not values, so we can track window boundaries. Okay, and then loop is starting. We iterate, so this for loop here. So we iterate through the array using index I, which says that the right pointer of the window, like which represents the right pointer of your window. And if Deque length and Deque is less than your I minus k, then we are removing elements out of window. Okay, so we are shifting the Deque and we are removing the elements. Here, what is happening is, so what we are doing is, so first we remove the elements that are outside the current window. If an index is too old, or for example, if it's no longer useful, then after that, what we did is we are removing all smaller elements from the back because they can never become the maximum again. So this is the most important part. As I was telling that the front will only have the maximum value. So that's why this logic runs like this. After that, we will add the current element. We are doing Deque dot push I here. Okay. And then we are capturing the result here. So what is it telling? For each window, what was the max at what point of time? So we are adding it here. Okay. The each, for example, 1 3, what is the max? 3. One of, if here it is 7 1 3 7, what is the max? 7. So answer would be 3 and 7, because if it ran 2 times, the window final would be 3 and 7. Now let's go and check out our example run here. So step I0, when you are at index, number 1 is pushed. Okay, fine. And so And one more thing before we go to the sample input output, at any point, the DQ is always in decreasing order. That's why the first element is always the maximum. Okay. And initially, so we have the 1 here. Then the index increases, we have number 3. So we did the removing smaller element, index 0. We removed it. So DQ after push is 3. Now we have only, so max from this window is 3 now. Think like this. Then you have number 2, I minus 1. So max, window max is 3 only still. And then again, we have 3 minus 3 minus 3, same window max is 3. Now actual the logic comes when this I4 comes because number is 5. Now you have to push out all the 3 things. So removing out of window index 1, 3, index 3, minus 3, index 2, minus 1, all these are pushed out and you have a window max 5 here. So if you understand the logic till now, let's see, till now, so you would have the answer 3, 3, 5. Let's see. Okay. And then we have here, we have I equal to 5 and number 3. 5, 3, obviously 5 is the window max is again we have 5. So how our final array is getting built? 3, 3, 5, 5. Now step I equal to 6, we have number 6. Well, this is the biggest number, so it will push out everything and the window max would be 6 here. Then it is 7. So I have given the input like this so that you understand. It will push everything out and window max will be 7. So what will be your final answer like this? Don't get confused here. We are finding maximum for every window. It's just not like what is the max number or something. That's why I was initially telling that the window is moving. What is the max? Initially 3. So we got minus 1, 3 was there. We got minus 3, 3 was there. Then 5 came into picture. Then again 5 came into picture. Then 6 and this 7. Okay. So, yeah. So this is how we were trying to find the maximum for window. And think of DQ as a leaderboard. Only the strongest elements survive. Okay. So this was about the one of the pattern where DQ is involved. Very important thing to notice is you have to use the Q, which is double-ended Q. Okay, and that's how you can reduce the ON solution. What you can try at home is not to use it and see how your logic works and which complexity you do. If you have a heap and you want to use the heap, how you can combine the pattern to decrease the complexity. So generally when interviews are taken, it's not about which pattern or how good you have memorized the pattern. If you are also into that direction, which shows that you're thinking correctly, your end output or whether you are able to print the end output correctly, that doesn't matter much. Okay. So with this video, I summarizes the sliding window pattern. So next video onwards, we will be starting the strings and the pointers related some problems which I think are very important for interview. So thank you so much. And if you like the channel, please do subscribe.